force Fx on the wedge and the rod is constrained to move vertically after releasing the rod system. Find the speeds when the wedge moves through a distance x. What are the, already I think you have come across this one, no? So what are the various forces that will be acting on the system? First, you should be aware of can you remember already? I think twice we have discussed this. So once again, in terms of work done, I'm bringing this one here. So this is the, say theta. Let me make M2 and this one let it be M1. Now this vertical walls, these are the walls which will not permit the rod to move towards right horizontally. So these are the things what you have come across. Yeah. The force F is applied here. What are the forces that will be acting? M1G, weight of this. Normal contact between them. N1 and that N1, show it here. The normal reaction N2 and the weight of this wedge M2G. Can we apply conservation of mechanical energy? The wedge moves by distance x. When this moves by distance x, what will happen to the rod? Rod will descend a distance y. Any the constant equation. So this is the inclined plane. This is a distance x. This is a distance y, and this is theta. This is theta. This will be theta. Any constant equation x and y. Y sin theta should be equal to x cos theta. Or y cos theta should be equal to x sin theta. In what direction the displacement must be equal. So as a normal reaction is zero, no? Normal contact between the rod and the wedge is non-zero. All the time the rod will be in contact with the wedge. So therefore the displacement perpendicular to incline must be equal. So therefore y sin theta, y cos theta should be equal to x sin theta. Will you agree this? So therefore we have to calculate, so x tan theta. So what is the displacement of the rod in terms of displacement of wedge? Y equal to x tan theta. Which all forces doing work? Normal contact N1, work done by N2 mg. So work done by all the forces. Initial kinetic energy, work done by normal contact, work done by the weight, work done by M2G, work done by N2 should be equal to final kinetic energy. This is the overall method here. Then initial kinetic energy, system is released from rest. Let's say work done by normal contact. How to judge this? So here component of normal reaction will act, N1 sin theta will act on the wedge, no? If you resolve this, N1 sin theta, here how much? N1 cos theta. Here N1 sin theta, and this will be N1 cos theta. I'm showing M1G like this. Look at now. Work done by.
In the equation, what about work done by force F, sir?
X agent is asking, no? So work done by the, I didn't write, here I'll write it. Work done by applied force equal to final kinetic energy. Okay, this much is it. So initial kinetic energy. Work done by normal contact. On the rod, it does negative work. N1 cos theta into y. On the wedge, it does positive work. So it does negative work. N1 sine theta into, this will be x, no? Yeah. Why N1 cos theta should be negative work here? The rod is moving. So one thing, I think, how the rod will move, vertically up or down? Rod will move vertically up or down? No, will move vertically up, no. If the wedge moves towards right, rod will move vertically up. So this should be vertically up. I'm not releasing from rest here. Some external force is applied. So here y will come upward actually. Then the constraint equation should change here. Yes, I'll change it, no problem. So this will be theta. Then also I think things are same, no? Y cos theta equal to x sin theta. There's no problem that one. Got it, no?
Sir, they didn't give the direction of x, sir. It can go in any direction.
X, no, through a distance x. I apply force, in what direction it will move? In the direction, the wedge will have displacement like this, no? I applied a force. See, anything. So like here we are taking like this, you know. So since I applied a force, I'll push the wedge will move towards right and the rod will move vertically up. So there won't be problem with the constraint equation. But here the problem arises, how it is moving all this thing. Now, this should be the positive. Keep it here. Work done by the weight. Work done by the weight. M1G into Y. It does negative work. Work done by M2G. 0. Work done by normal contact. I'm putting brackets also. It'll be easy for you to notice. Now, work done by applied force. F into X is equal to M Vx square. So this will be M2 Vx square plus M1 Vy square. So again, what is the problem with the Vy and Vx? Vy should be equal to Vx tan theta. Now look at the normal contact. We don't know again N1. Can you say this quantity equal to 0? N1 cos theta y should be equal to N1 sin theta x. That must be equal to 0, the bracket term. I'll put the next step. The square bracket term will be 0. Why it will be 0? Anybody, why it is 0? So substitute this constraint equation again. Y cos theta is equal to x sin theta. Will be 0. So what are the only forces doing work here? The applied force and the weight. Substitute this and get the speed of the blocks. I think you have to be very careful here. On one side, constraint will come. Then again, you have to list out all the forces, work done by them. So this is equation 1. Solving equation 192, you'll get the required answer. Normal contact force, N1 does work. Net work done by normal contact between the rod and the wedge is 0. The bracket term. Here I'm showing this. Shall I scroll down?
Sir,
Yeah.
sir,
Ah.
sir, we will get y cos theta plus x sin theta is 0, no, sir. Why
It's
are we only taking magnitude?
it's a relationship, no? The displacement perpendicular to incline must be zero. I don't know. You're thinking mathematics. It's a there's a how displacement of wedge and the rod are related. There's the equation, no?